Welcome to the Philosophical Odysseys podcast. You know, history is, it's so often taught to us as this really disjointed, almost, jagged series of isolated events.
Oh, yeah, completely. Like a bunch of disconnected islands.
Right, exactly. We get the ancient Greeks in one semester, maybe, a quick nod to the Romans, and then boom, the curtain falls, the lights go out, and we are suddenly dropped right into the European Renaissance.
Yeah, skipping over, 1,000 years of human progress.
Literally, we're taught to look at history as if all that brilliant art, architecture, and science just spontaneously materialized out of the Dark Ages like magic. But today, we are taking a massive stack of historical texts, treatises, and philosophical analyses, and we are going to look at history not as a fragmented timeline, but as an unbroken continuous chain.
Which is honestly the only way it actually makes sense.
Exactly.
Wow.
So for this deep dive, we are diving deep into the scientific legacy of the Islamic Golden Age. We are talking roughly the 8th to the 14th centuries.
Right, a massive chunk of time.
Yeah, and we're going to see how this incredible era didn't just preserve ancient wisdom. It acted as the ultimate bridge. It rescued it, deeply enriched it, and directly sparked the Enlightenment and the modern world as you and I know it today.
It's a huge shift in perspective.
It is. But we are looking at this through a very unique lens today. We are viewing this historical era through the lens of Masonic philosophy.
Which is a really fascinating angle to take.
Right, specifically that universal human quest to move from darkness, which means ignorance, superstition, and dogma, into light, which represents knowledge, reason, and brotherhood.
Yeah, and it is a profoundly effective framework for looking at history. Because when you adopt that specific lens, the development of human science and philosophy is no longer just a dry table of contents or a timeline of dead facts to memorize.
Right, it's not just rote memorization anymore.
Exactly. It actually becomes a gripping narrative. It becomes the story of humanity's shared intellect and conscience, constantly fighting to strip away the darkness of bigotry, the darkness of tribalism, and, quite frankly, the darkness of intellectual laziness.
Oh, that's a good way to put it. Intellectual laziness.
Yeah, because they were fighting all of that just to reach a state of illumination.
Okay, let's unpack this. Imagine you are living in a beautiful, modern house. You love the architecture, you love the amenities, the Wi-Fi is great.
Always need good Wi-Fi.
Always. But then, one day, you decide to dig into the basement. You start scraping away the dirt, and you discover that the bedrock foundation of your own house was secretly poured centuries ago by brilliant engineers you've never even met, and honestly, barely even heard of.
Wow. Yeah, that's a powerful image.
Right. You thought your house was built yesterday, but its roots go back 1,000 years. That is exactly what the Islamic Golden Age is to modern science and the Enlightenment. We are comfortably living in the house they helped build.
That is a perfect way to conceptualize it. I mean, knowledge is truly most valuable when it is understood as a shared human inheritance. It doesn't belong to one era, it doesn't belong to one geography, and it certainly doesn't belong to one religion or one empire. It is like a baton passed in a global relay race.
I love that relay race analogy.
Yeah, and what our sources do today is trace exactly how that baton was passed, refined, and carried forward during a time when, well, much of the Western world had just dropped it.
Yeah, they dropped it hard. So to really understand how this unbroken chain of knowledge was forged, I think we have to start by looking at the physical and cultural space that made it all possible.
The workshop.
Exactly, the workshop. We need to move from the broad, abstract concept of a golden age down to its absolute geographic and intellectual epicenter. We are heading to Baghdad under the Abbasid Caliphate.
Yes, and the context of the Abbasid Caliphate is absolutely vital here. We're looking at the conscious, deliberate patronage of caliphs, specifically figures like Harun al-Rashid, and later, quite prominently, his son Al-Mamun in the late 8th and early 9th centuries.
So they were the ones bankrolling this whole operation.
Oh, entirely. Now, they didn't just passively allow scholarship to happen in the background while they, focused on conquest or whatever. They actively funded it, protected it, and made it a core pillar of their empire.
Wow.
They created an absolute sanctuary for the pursuit of knowledge. In English, we know this legendary institution as the House of Wisdom.
The House of Wisdom.
Right.
I mean, even the name has this incredible weight to it.
It really does.
But I was reading through our sources, and they are very clear to point out a crucial detail here that breaks a lot of modern assumptions. This was not just a library.
Right, definitely.
Because when you and I hear library, we tend to think of quiet rooms, dusty books, people shushing each other, maybe a lone scholar hunched over a desk in the corner.
Yeah, exactly. Very isolated.
Right. But the House of Wisdom was nothing like that. It was a living, breathing ecosystem. You had Arabs, Persians, Turks, Christians, Jews, and Muslims, all walking the same halls, working side by side.
What's fascinating here is how directly this historical reality mirrors the Masonic ideal of the lodge.
Oh, okay. Tell me more about that connection.
Well, if you look at what a lodge represents in that philosophical tradition, it isn't just a building. It is a protected, sacred space, a functional precursor to this idea, really, where individuals gather not based on their religious dogma and not based on their ethnic background or societal rank.
So those things just didn't matter inside.
Exactly.
Yeah.
When they enter that space, those external divisions are supposed to be completely left at the door. They gather for the shared, constructive goal of building a better world through universal brotherhood and the pursuit of truth.
I'm trying to wrap my head around just how radical that must have been at the time. I mean, you have a world outside that is constantly at war over territory and religion, but inside this specific building in Baghdad, the only thing that matters is the work itself.
It was incredibly radical. The House of Wisdom is essentially a historical prototype of this exact ideal. It was the physical manifestation of a really profound philosophical principle.
Which is?
The idea that knowledge is a universal human heritage that simply cannot be constrained by cultural or religious borders. They realized that if you actually want to understand the universe, you need every perspective available.
Yeah, you can't just look at it from one angle.
Right. They created a space where the shared pursuit of truth superseded tribal or dogmatic divisions.
Which brings us to the actual engine inside the House of Wisdom. The sources call it the Great Translation Movement.
Yeah, and it was massive.
Yeah, this wasn't just a few guys translating a couple of scrolls on a weekend. This was a massive, unprecedented, state-funded effort. They were taking the greatest works of Greek, Persian, and Indian thinkers. We are talking Plato, Aristotle, Euclid, Galen, Ptolemy, and translating them all into Arabic.
A monumental task.
But hold on, let me play devil's advocate for a second here.
Go for it.
Wait, isn't translation just copying? I mean, you are taking someone else's brilliant idea, looking at the Greek, and just writing down the equivalent word in Arabic. How is that an intellectual leap?
That is a brilliant question, and honestly, it is a very common, very pervasive misconception that our sources spend a lot of time refuting. The Great Translation Movement was absolutely not a passive reception of ancient wisdom.
Okay, so it wasn't just them acting as scribes.
No, it wasn't just dictation at all. It was an active, highly critical engagement.
What does that mean in practice, though?
It means that when these scholars in the House of Wisdom sat down to translate a text, say a really complex astronomical treatise by Ptolemy or a philosophical argument by Aristotle, they actually tested it against reality.
They tested it.
Yeah. They didn't view the ancients as infallible gods. They viewed them as colleagues from the past who might have made mistakes.
Oh, wow.
So they questioned the ancient assumptions. If they found a mathematical proof that was flawed, they corrected it in the margins. If they found a medical theory that didn't match their own clinical observations, they updated it.
That's amazing.
And most importantly, they synthesized different traditions. They would take a Greek philosophical concept, merge it with Indian mathematics, and build an entirely new framework upon them.
So they were essentially fact-checking Aristotle.
Exactly.
They were taking the smartest guys from antiquity and saying, well, good start, but let's run the numbers again.
Exactly. They were fact-checking antiquity. And this principle, taking existing knowledge, testing it, refining it, and building upon it, is the absolute cornerstone of all progressive thought systems.
Makes total sense.
The operational philosophy of the House of Wisdom was to bring diverse minds together to elevate human understanding. It wasn't just about preserving the past in amber. It was about using the past as raw material to forge the future.
So if the House of Wisdom is the workshop, right, the protected space where all this intense collaboration and refinement is happening, we need to talk about the master craftsmen inside that workshop.
We do. We need to look at the people doing the work.
Exactly. Our sources highlight 3 specific intellectual archetypes to show how this chain of knowledge evolved. It moves from pure, abstract thought all the way down to physical, mechanical reality. And the first step of any grand design, before you build anything, is theory. The why.
Yes, the philosopher-theorist. You cannot build a system or a machine without first understanding the underlying laws of reality. And for this, our sources look to one of the most towering intellects in human history, a man known in the West as Avicenna.
Avicenna. I mean, even if you've never studied history, his name just sounds like it carries weight.
It really does. It's iconic.
Just to give you listening an idea of the sheer scale of this single individual's impact, let's look at his most famous work. It's a massive encyclopedia called the Canon of Medicine.
The canon of medicine is monumental. And again, this goes back to your earlier point. He didn't just copy older texts. Avicenna didn't just write down a list of folk remedies or translate Greek medicine word for word.
Right.
He systematically compiled, organized, and categorized virtually all known medical knowledge from Greek, Roman, Persian, and Indian sources. But then he did something crucial. He integrated it with his own extensive, rigorous clinical observations.
Yeah, I read that he actually introduced concepts that sound incredibly modern to us today. Like the idea of quarantine to stop the spread of contagious diseases, or the idea that diseases can be spread through water and soil.
He did. He laid down basic rules for clinical drug trials, too.
Wait, really? Drug trials back then?
Yes, like how to test if a medicine actually works, ensuring you test it on different body types, testing it over time, making sure the effect is actually reproducible.
Wow, so he wasn't just guessing.
No, he was introducing the scientific method to pharmacology. He created a cohesive, logical system out of scattered, sometimes contradictory knowledge. The result was so definitive, so far ahead of its time, that it served as the absolute standard medical textbook in European universities for over 600 years.
Let that sink in for a second. 600 years.
It's incredible.
Imagine a medical textbook written today, in our modern world, still being the absolute gold standard that doctors rely on in the year 2600. It's mind-boggling.
It really puts his genius into perspective.
It does. It shows a profound application of pure reason to the most fundamental human concern, human health and life itself. But here's where it gets really interesting. Avicenna wasn't just a physician.
No, he was much more than that.
Right. He wasn't just looking at the human body. He was a philosopher who dove into the deepest, most abstract waters of metaphysics. He wanted to understand the very nature of existence itself.
He did. He was searching for the fundamental architecture of reality. Because in his view, to understand the body, you must understand the world it lives in. And to understand the world, you must understand why anything exists at all.
That is deep.
It is. And in doing so, he developed a vital philosophical distinction between what he called possible being and necessary being.
Okay, walk us through that, because the sources get pretty dense here. It's a deep concept. What exactly does he mean by possible being?
It is deep, but it is beautifully, rigorously logical. Avicenna argued that everything we observe in the universe, you, me, the stars, the trees, the chair you're sitting on, is a possible being. This is sometimes translated as a contingent being.
Contingent meaning it depends on something else.
Meaning its existence relies on a cause outside of itself. You exist because your parents existed. A tree exists because a seed was planted, the soil had nutrients, and the sun shone. The chair exists because a carpenter built it.
Right.
Everything in the observable universe is part of a massive, interconnected chain of cause and effect.
Right. Nothing I see around me just popped into existence for no reason. Everything is reliant on something else having happened first.
Exactly. But Avicenna applies strict logic to this observation. He says, logic dictates that this chain of cause and effect cannot go backward infinitely.
Because then it would never start.
Exactly. You cannot have an infinite regress of contingent things. Because if the chain goes back forever without a starting point, then the chain itself has no foundation. There must be an anchor. There must be an ultimate uncaused first cause that kicked the whole thing off.
Something that doesn't rely on a parent or a seed or a carpenter. Something that just is.
Precisely. And that anchor, that first cause, is what he termed the necessary being. It is a state of pure reason, a source of existence that needs absolutely nothing else to exist. Its very essence is existence itself. It cannot not exist.
And this is where the sources draw a brilliant parallel to the overarching theme of our deep dive today. This purely rational, non-dogmatic first cause that Avicenna reasoned out using strict logic, it connects directly to the liberal Masonic concept of the great architect of the universe.
It's a very clear through line.
Yeah. Now, we need to clarify what that means, because great architect sounds like a very specific religious figure. But the sources emphasize that in this context, it's quite the opposite, right?
If we connect this to the bigger picture, the concept of the great architect in the liberal Masonic philosophical tradition is deliberately not tied to the specific dogma of any single religion.
Okay.
It is not an old man in the clouds handing down specific rules for dietary habits or, telling you which tribe to go to war with. Instead, it is viewed as a unifying philosophical principle.
Ah, I see.
It is a symbol of ultimate reason, ultimate order, and the grand design of reality, very much like Avicenna's necessary being.
So it's a way to acknowledge a higher order without getting bogged down in theology or religious infighting.
Exactly. Because it is a principle rather than a personalized dogmatic deity, it acts as a massive unifier. It allows people of incredibly diverse faiths, Christians, Muslims, Jews, deists, even certain secular philosophers, to gather under one conceptual roof without conflict.
That's brilliant.
Yeah. They can all look at the complexity of the universe, acknowledge that there is an underlying architecture or a necessary being, and agree to call it the great architect, while leaving the specific religious details to individual conscience.
It's a symbol that everyone can interpret through the absolute freedom of their own mind. So Avicenna used pure intellect, pure logic, to arrive at a unifying principle. He provided the theoretical foundation, the ultimate, why that allows for a universal brotherhood of thought.
Exactly right.
But as we know, a brilliant theory is completely useless if you don't have a language to express it, or a system to actually apply it to the world.
Right.
You can know the universe has an architecture, but you still need the math to build a bridge.
Which brings us to the second archetype in our sources. The intellectual baton passes from the theoretical why to the systematic how. We are moving from the philosopher who contemplates existence to the systematizer who organizes it.
And when we talk about systematizing the world, we have to talk about a man named Al-Khwarizmi.
Oh, absolutely.
I was blown away reading the sources on this guy. Because when you think of 9th century mathematicians, you don't usually think about how they impact your Tuesday morning.
No, you usually think of dusty scrolls.
Right. But the everyday, mundane impact this one individual has on our modern lives is staggering. He's often called the father of algebra.
Rightly so. He wrote a groundbreaking book on calculation that fundamentally changed the trajectory of human progress. The primary reason the Hindu-Arabic numeral system, the numbers 0 through 9 that you and I use every single day, spread through the Middle East and eventually into Europe, is because of Al-Khwarizmi's work.
Let's do a quick thought experiment for the listener. Think about what it was like before this system was adopted in the West. Think about Roman numerals.
No.
Imagine you are a merchant in the 10th century, and you are trying to do long division with Roman numerals. Try doing complex accounting, calculating interest, or doing advanced physics with V's and X's and L's and C's.
It is nearly impossible. Roman numerals are great for inscribing dates on monuments or movie sequels, but they are a nightmare for computation.
Yeah, try carrying the V.
Exactly. You cannot easily carry the 1. You cannot easily represent fractions. And most importantly, the Roman system lacked a placeholder.
The concept of 0.
Yes, 0. The introduction of this new numeral system, and crucially, the revolutionary concept of 0, acted like a massive software update for the entire globe.
A software update that's perfect.
Without 0, positional notation where the value of a digit depends on its place, like the ones, tens, or hundreds column, just doesn't work. 0 is the empty space that makes the rest of the numbers function as a scalable system.
Software update really is the perfect way to put it. It was like going from an abacus to a supercomputer. It provided the necessary operational language for complex calculation, global commerce, and advanced science.
It completely changed the game.
But Al-Khwarizmi didn't just introduce the numbers, right? The sources emphasize that he created a systematic, repeatable method for solving problems.
He took mathematics from being a collection of clever, isolated tricks that only a few geniuses knew, and he elevated it into a rigorous, universal language. He provided step-by-step procedures to solve linear and quadratic equations. He systematized inheritance laws, trade calculations, and surveying.
And our sources are full of these amazing linguistic Easter eggs regarding his work. It shows just how deeply his thought is embedded in our everyday vocabulary. For example, the word algebra. Where does that actually come from?
It comes directly from the title of his most famous book. One of the fundamental operations he described for balancing equations was moving a negative term to the other side of the equation to make it positive. The Arabic term he used for this operation was al-jab, which essentially means restoration or balancing.
Al-jab.
Yeah, and over centuries of translation and use in Europe, al-jab simply became algebra.
That's incredible. And it doesn't stop there. Think about the word algorithm. It's the ultimate buzzword today. It's dictating the modern digital world, dictating what you see on your social media feed, how computers process data, how AI learns. The word algorithm is literally just the Latinized version of his own name.
Exactly. When his works were translated into Latin, they often started with the phrase Dixit Al-Khwarizmi, meaning thus spoke Al-Khwarizmi. Over time, his name, Al-Khwarizmi, became synonymous with the concept he championed, which is a step-by-step mechanical procedure for solving a mathematical problem.
Wow.
The fact that his very name is now the foundation of computer science is a testament to his genius as a systematizer.
Oh, and I have to share this other mind-blowing fact from the sources about the origin of the letter X in math. Everyone who has ever taken a math class knows we are always solving for X. But why X?
It's a great story.
So in Al-Khwarizmi's time, they didn't have all the neat mathematical symbols we have today. He had to write out his algebraic problems using regular text. When he had an unknown variable, he used the Arabic word shay, which just translates to thing.
Right, just a generic placeholder.
Yeah. So he's writing, I have 5 apples plus a certain thing equals 10 apples. When his works were translated and reached Spain, the Spanish scholars didn't have a good letter to represent that sh sound. So they transcribed share using the classical Greek letter ch, which looks like an X, writing it as Z.
XAY.
Exactly. And over time, as scholars wrote it faster and faster, Z was just abbreviated to the single letter X.
That is a wonderful illustration of the unbroken chain we are talking about. An Arabic word for thing in the 9th century, filtered through Spanish translation, becomes the universal symbol for the unknown in modern global mathematics.
It's just wild how interconnected it all is.
It really is. But while Al-Khwarizmi is undeniably foundational, our sources make sure we don't skip over the other titans of systematization who took these tools and pushed them even further.
Right, because once you have the language of algebra, you can start doing some wild things.
Yeah.
The sources bring up Omar Khayyam. Now, a lot of people listening might know him as a famous poet, the author of the Rubaiyat.
Yes, very famous for his poetry.
But the man wasn't just sitting under a tree writing poetry. He was an absolute beast in mathematics.
He was a true polymath. In mathematics, he went far beyond linear equations. He pioneered what we now call analytic geometry, blending algebra and geometry to solve cubic equations. And he was doing this centuries before the French mathematician René Descartes, who usually gets the sole credit in Western textbooks.
Centuries before.
Yeah. Furthermore, he explored the binomial theorem and the properties of a triangular array of binomial coefficients, what we now universally call Pascal's triangle, hundreds of years before the French mathematician Blaise Pascal was even born.
It's like finding out that someone invented the airplane in the 1400s.
Basically, yeah.
And we have Al-Biruni. The sources state that his impact on the sciences was so profound that historians sometimes refer to the first half of the 11th century simply as the Biruni era.
Al-Biruni was arguably one of the greatest scientific minds in all of human history. He was an astronomer, a mathematician, an anthropologist, and a physicist.
He did it all.
He really did. Among many other achievements, he is credited with inventing the modern concept of mathematical functions, and he was the one who integrated trigonometry into an independent, sophisticated science rather than just a minor subfield of astronomy.
Okay, I have to stop you there because there's one specific story in the sources about Al-Biruni that absolutely blew my mind, and we need to deep dive into the mechanics of it. It's about how he measured the Earth.
Oh, this is a phenomenal story.
Now, I want you to explain exactly how he proved the Earth was round, and more importantly, how he calculated its exact size without ever leaving the ground.
It is an absolute masterclass in applying systematic observation and trigonometry. So, to set the stage, he first needed to definitively argue against the flat Earth theories that still lingered in some circles, though many scholars already accepted a spherical Earth.
Okay, so how did he prove it to the skeptics?
He used pure celestial observation. He noted that as an observer travels further north, the number of stars visible in the night sky actually changes. Certain stars that were visible in the south disappear below the horizon, and new stars appear in the north.
Because the ground is curving under them.
Exactly. This shifting perspective, this change in the visible canopy of the heavens, is physically only possible if the observer is traveling along a convex, curved surface.
Okay, so that proves the curve. But proving it's curved is one thing. Measuring the entire planet with 11th century tools is another. Walk me through the actual method.
He used brilliant geometry. He realized he didn't need to walk across the whole continent. He just needed a mountain and a flat plain.
Just a mountain and a plain.
Yeah. So while traveling in what is now Pakistan, he found a fort at Nandana, situated on a high mountain that offered a completely clear, unobstructed view of a perfectly flat horizon. In his case, it was a vast, flat plain stretching out like a sea.
Got it. A mountain and a flat horizon.
Oh.
What's step one?
Step one is figuring out the exact height of the mountain. He couldn't drop a tape measure. So he went down to the flat plain. He picked 2 different spots on the ground, a known distance apart. From each spot, he used an instrument called an astrolabe.
Let's pause and define that for the listener because it's a crucial piece of technology. What is an astrolabe?
An astrolabe is essentially an intricate, handheld brass computer used for astronomy and navigation. It's a disc covered in scales and dials with a rotating pointer.
Like a really complex protractor?
Kind of, yeah. You hold it up by a ring so it hangs perfectly vertical, and you sight an object, like a star or, in this case, a mountain peak, along the pointer. You then read the angle marked on the edge of the disc. It allows you to measure the exact altitude of an object above the horizon.
Okay, so he's on the flat ground, looking up at the mountain peak through this brass dial from 2 different spots, noting the angles.
Exactly. Using those 2 angles and the known distance between his 2 observation spots, he used basic trigonometry to calculate the exact height of the mountain. That was the hard part.
And step 2.
Step 2 was the genius part. He then climbed to the very top of that mountain.
He's at the peak.
He's at the peak. He takes out his astrolabe again. He holds it perfectly level, establishing a line of sight straight ahead, perpendicular to gravity. Then he looks slightly downward, sighting exactly where the flat plain meets the sky, the distant horizon. Because the Earth is curved, the horizon actually dips down away from your eye line. He used the astrolabe to measure the exact angle of that dip.
So just to picture this, a guy standing on a mountain peak in the 11th century with a brass dial measuring the slight angle between looking straight ahead and looking down at the horizon.
Precisely. And here is where Al-Khwarizmi's systematized math comes in. By knowing just 2 things, the exact height of the mountain and that specific tiny angle of the dip to the horizon, he could plug those numbers into a complex trigonometric formula and calculate the radius of the entire planet.
And what was the result? Let's talk accuracy.
His calculation of the Earth's radius was roughly 6,338 kilometers. Today, modern satellite measurements using lasers, GPS, and space-age technology put the Earth's radius at about 6,378 kilometers.
He was off by 40 kilometers.
40 kilometers, 1,000 years ago, with a brass dial and a notebook.
That is just, it gives you goosebumps. It really does.
It's astounding.
It is the ultimate triumph of the mathematical system. It proves that the human mind, armed with reason and a systematic language, can reach out and measure the universe. But, as our sources point out, a system is still just an abstract tool. We have the foundational medical theory of Avicenna. We have the massive mathematical systems of Al-Khwarizmi and Al-Biruni. But how does this abstract systematic knowledge actually step off the parchment and change the physical world?
Right. Theory isn't enough on its own.
Exactly. You can't drink a math equation. We have to move from the mind to the hands.
Which brings us to the 3rd archetype in our roadmap, the practical engineer, the what for. Theory and system must ultimately culminate in physical, beneficial application. And for this, our sources introduce us to a true visionary, Al-Jazari.
Al-Jazari. When I was reading his section, I felt like I was reading science fiction. The sources describe him as the master of applied science, a pioneer of cybernetics, and an early genius of robotics.
His masterpiece, written in 1206, is wonderfully titled The Book of Knowledge of Ingenious Mechanical Devices. And the word ingenious is almost an understatement.
I bet.
He wasn't dealing with abstract numbers or celestial angles. He was mastering the physical laws of nature, water, air, gravity, and friction.
The devices meticulously detailed in this book are incredible. Let's walk the listener through a few. There's the Peacock Fountain, which was essentially an automated wash basin where mechanical birds would dispense water and then offer soap and towels to guests.
It's brilliant hospitality.
Yeah, and he designed automated servants that could pour drinks at a party. But the absolute crown jewel, the one that blew me away, is the elephant water clock. Can you explain how this thing actually worked?
The elephant water clock is a marvel of early engineering. Imagine a massive, ornately decorated, life-size model of an Indian elephant. Riding on top of the elephant is a mahout, or driver. On the elephant's back is a small tower, and perched on the tower is a mechanical bird. Around the tower are mechanical dragons.
Sounds like a parade float.
It looks like a lavish piece of art, but inside the belly of the elephant is a highly precise time-keeping mechanism.
How does it keep time? I'm assuming no batteries.
No batteries, no spring coils. It uses water. Inside the elephant is a large water tank, Floating inside that tank is a deep bowl with a tiny, precisely calibrated hole in the bottom. Over the course of exactly half an hour, water slowly leaks through that hole into the bowl.
So the bowl is slowly sinking.
Exactly. It acts as a timer. Once half an hour passes, the bowl becomes too heavy and sinks. As it sinks, it pulls a string. This string triggers a massive chain reaction of mechanisms.
Okay, what happens when the string is pulled?
First, the mechanical bird on top of the tower spins around and sings. The sinking bowl then releases a metal ball that drops into the mouth of a mechanical dragon. The weight of the ball causes the dragon to swing downward on a pivot. The dragon drops the ball into a brass cymbal, creating a loud clang to announce the half hour.
So it's an auditory alarm clock.
Yes, but here's the genius part. After dropping the ball, the dragon swings back up, pulling a chain that is connected back to the sunken bowl. It yanks the bowl back up to the surface of the water, resetting the entire mechanism so it can start slowly sinking and timing the next half hour. All while the Mahout figure strikes the elephant to simulate movement.
Wait, so the machine resets itself?
If we connect this to the bigger picture, it is vital to understand what we are looking at here. These were not mere toys or party tricks for the elite. They were profound demonstrations of sophisticated mechanics. The machine resetting itself is what engineers call a closed-loop system, or a feedback mechanism.
Can you define a feedback mechanism for the listener?
A feedback mechanism is a system where the output of an action is used to control or adjust the next input. Think of your thermostat at home. You set it to 70 degrees. When the house gets too cold, it triggers the heater. The heat is the output. When the room hits 70, the thermostat senses that heat and turns the heater off. It regulates itself based on its own actions.
And Al-Jazari was doing this with water, strings, and metal balls in the 13th century.
Precisely. He utilized hydraulics, complex gear balancing, air pressure, and early forms of these feedback loops. These are the exact same foundational mechanical principles that drive modern automation today. He was building machines that could regulate themselves, work continuously, and perform complex sequential tasks.
And his influence didn't just disappear into the sands of time. The sources point out that his mechanical designs, his use of camshafts, his use of double-acting pumps to draw water, they had a direct, measurable influence on later Renaissance thinkers. We were talking about people like Leonardo da Vinci. Da Vinci was sketching mechanisms that Al-Jazari had perfected centuries earlier.
Yes. Al-Jazari represents the ultimate completion of the cycle we've been tracking. Think about the progression. First, you learn the underlying principles and laws of the universe. That's the theory of Avicenna.
Right.
Then you develop a disciplined mathematical language to organize those principles. That's the system of Al-Khwarizmi and Al-Biruni. And finally, you apply that systematized knowledge to build tools, pumps, and clocks that practically benefit humanity in the physical world. That's the action of Al-Jazari.
It synthesizes the entire progression perfectly, from theory to system to action.
Exactly. And this maps perfectly to the philosophical ideal of the builder that we established at the beginning of this deep dive. Whether you look at it through the lens of Masonic philosophy or just basic humanistic progress, it is the journey from abstract contemplation to systematic discipline, culminating in tangible, beneficial action in the world. Knowledge isn't meant to stay in the mind. It's meant to build a better reality.
Okay, so this brings up a massive critical question that I kept asking myself while reading the sources. We have this glowing treasury of systematized, practical knowledge built up in the East. We have hospitals, algebra, global measurements, and automated machines. But how did it cross over?
That's the million-dollar question.
Right, because at this exact same time, much of Western Europe was languishing in what we historically call the Dark Age, relatively speaking.
Huh.
If knowledge stays isolated in one empire, no matter how grand, it eventually stagnates or gets destroyed by war. It has to flow to survive.
That is a crucial historical point. Knowledge is kinetic. It requires movement. And the golden era of the Abbasids eventually faced its own decline, most notably with the devastating Mongol invasions that literally destroyed the House of Wisdom and threw its books into the Tigris River.
A massive tragedy.
It was. But before that happened, the knowledge had already begun to leak out. The sources identified two main geographical arteries for this intellectual transfer to the West. Al-Andalus, which was Muslim-ruled Spain, and the island of Sicily.
So these were the borderlands.
Yes. These were the frontier zones, places where different cultures, armies, and merchants collided, mingled, and eventually had to exchange ideas. And the focal point of this massive exchange, the real engine of the transfer, happened in the 12th century, specifically at the Toledo School of Translators in Spain.
Tell me about Toledo. What was happening there?
In the late 11th century, Christian forces conquered the city of Toledo from its Muslim rulers. But when they walked into the city, they didn't just find gold and weapons. They found massive, sprawling libraries. Exactly. The new rulers realized the staggering intellectual value of what they had captured. And so the Toledo School of Translators emerged. You can think of it as the European Western equivalent of the House of Wisdom.
So another one of those rare protected spaces.
Precisely. Under the patronage of forward-thinking archbishops, it became a sanctuary. Here you had Christian scholars arriving from all over Europe, Jewish scholars who lived in Spain and spoke both Arabic and the local Romance languages, and Muslim scholars who remained in the city, all sitting shoulder to shoulder.
That's incredible.
Yeah, and they collaborated to translate these monumental Arabic texts into Latin, which was the universal language of European scholars.
I'm picturing this incredible game of intellectual telephone.
Yeah.
A Muslim scholar reads Avicenna's Arabic aloud, translating it into the local Spanish dialect. A Jewish scholar hears the Spanish, debates the nuance, and then a Christian scholar translates that Spanish into formal Latin to be sent back to Paris.
That is exactly how many of the translations were done. It was a deeply collaborative, multicultural effort. They were taking Avicenna's canon of medicine, Al-Khwarizmi's works on algebra, all those Arabic commentaries, refinements, and corrections on Aristotle, and translating them into Latin.
And what was the result? When these books hit Europe, what happened?
The impact of this sudden influx of translated texts cannot be overstated. It was an intellectual earthquake. It was the primary catalyst for the European Renaissance.
Really, the primary catalyst.
Without a doubt. This massive flood of systematized knowledge into Europe directly fueled the birth of the first great European universities, places like Paris, Oxford, and Bologna. Scholars in Paris were suddenly reading Avicenna's logic. Scholars in Oxford were suddenly studying Al-Biruni's math. It was the intellectual kindling that ignited the Enlightenment.
They weren't just passively handing over old books. They were passing a living, burning torch across the sea.
Historically and philosophically, it is the ultimate act of spreading the light. It proves, without a shadow of a doubt, that human progress doesn't happen in a vacuum, and it certainly doesn't belong to one tribe or one religion. Progress relies entirely on openness, on communication, and on the willingness to accept wisdom regardless of its cultural, geographic, or religious origin. The diverse group of translators in Toledo were essentially intellectual midwives. They helped to birth a new era of rational inquiry in the West, built directly on the foundations poured in the East.
So what does this all mean? We've covered centuries of history, massive intellectual movements, translating Greek to Arabic to Latin, measuring mountains and building mechanical elephants. How do we synthesize all of this? How do we bring this epic historical journey back down to you, the listener, right now in the 21st century?
Our sources offer a truly masterful way to summarize this entire deep dive, returning to that core metaphor from Masonic philosophy we established at the beginning. It is the allegory of the ashlar, specifically the journey of humanity from the rough ashlar to the perfect ashlar.
The rough stone to the perfected stone. Let's define those terms clearly for everyone. What is an ashlar?
An ashlar is simply a block of stone used by stonemasons in building a structure. The rough ashlar is the stone exactly as it comes out of the quarry. It is unshaped, chaotic, jagged, and useless for building a stable wall.
Okay, and metaphorically?
Metaphorically, it represents raw, unrefined human potential. In our historical context, it represents the raw, often ignorant state of early antiquity. It is the human mind before it has been disciplined by education, science, and reason.
It's a mind full of jagged edges, prejudices, superstitions, and untested dogmas.
Yes. Now think of the scholars of the Islamic Golden Age, figures like the philosophical Avicenna, the systematic Al-Khwarizmi, the observational Al-Biruni, and the practical Al-Jazari. They were the master craftsmen of human history.
The ones working the stone.
Exactly. They took this rough stone of human knowledge, gathered from Greece, India, and Persia, and they went to work in the lodge of the House of Wisdom. They used the chisel of disciplined inquiry and the mallet of pure reason to chip away at the rough edges of superstition, flawed logic, and scientific error.
They tested it, they translated it, they refined it. They didn't just accept the rough stone, they worked it.
And the result of centuries of this intense, collaborative labor was the perfect ashlar, a beautifully shaped, systematized, and refined block of knowledge. And it was this perfected stone, this systematized science that was passed through places like the Toledo School into the West. It served as the very cornerstone upon which the European Renaissance, the Enlightenment, and the modern scientific world were built.
That is an incredibly powerful image to leave on, because it means that the Temple of Humanity, this massive, shared, cross-generational project of building a better, more enlightened world, is still under construction.
It's never truly finished.
No, it isn't. It didn't stop in Baghdad, it didn't stop in Toledo, it didn't stop with Da Vinci or Newton, and it hasn't stopped today. The ultimate lesson from these ancient architects is that we all, especially you listening right now, have a duty. We have to take the rough ash lore of our own character and the massive, raw, chaotic flood of information in our modern world and use reason, discipline, and collaboration to shape it into something that builds a better future.
We are all inheritors of this massive tradition, and therefore we are all responsible for its continuation. Which leads to a thought I think is deeply worth dwelling on as we wrap up.
What's that?
Consider this. If the very algorithms powering the device you are using to listen to us right now, the code directing your life, are named after a 9th century mathematician from a distant empire who just wanted to figure out a better way to do accounting, well, what seemingly small, everyday intellectual tools or ideas are we forging right now today that might serve as the vital building blocks for another renaissance 600 years in the future?
Just remember, that foundation under your house goes so much deeper than you could ever imagine. Don't forget to follow us and subscribe to stay updated on our latest episodes, and never miss a step in this odyssey of thought. Until next time, keep questioning.